reproduction. Now we move to the next component of Cooley's tube, and it is target. Now this is a very important component. Now the target, it consists of a block in which a piece of tungsten, usually, or it can be molybdenum or any other high atomic number metal, is basically placed into it. Now there are certain requirements. Whatever is used as a target and it is fitted in copper block. So our target, which is usually tungsten, molybdenum, is fitted in a block which is made up of copper. Now this target should have certain desirable properties. The very first desirable property is that it should have high melting point, because fundamentally lot of heat is generated when we go for X-ray production. So our target should have preferably high atomic number so that it doesn't melt or it doesn't damage while X-rays are being produced. Now, as I said, usually we employ tungsten as a target. Now the melting point of tungsten is highest among metals, and it is 3410 degrees Celsius. The second desirable property or characteristic of target is it should have high thermal conductivity. Again, as I said, enormous heat is generated in X-ray production, so we would like this heat to be carried out of the system as early as possible without damaging the equipment. So it is desirable that target should have high thermal conductivity. Now the third, which is very important property of target to be used in X-ray production, is it should have high atomic number. Now let's understand why the target used in X-ray production should have high atomic number. Basically, for X-ray production we need a strong nuclear electric field that we'll see just in the next topic. So to produce X-rays we need a strong electric field created by nucleus. Now to have a strong nuclear electric field, atomic number of the nucleus must be very high. And the second reason is, in high atomic number elements, the energy difference between various energy levels is of order of energy possessed by X-ray photon. So I repeat it, in high atomic number element, the energy difference between any two quantum states, it lies in the region of X-rays. That's why it is desirable to have a high atomic number. Then we have the third component, which is source of high potential difference. So normally we can use AC or DC as a source of high potential difference, and this source is used to accelerate electrons which are emitted from electron gun, that is filament, and these accelerated electrons, after achieving a high energy, strike the metal target to produce X-rays. Normally the order of potential difference which we use in X-ray production is of 25,000, 30,000. That is the average potential difference we employ. So we can use AC source, where we will be using step-up transformer to step up the voltage to the desired level, or we can use DC source. And then we have a vacuum system. Now here our intention in the equipment is to produce X-rays. Now while these electrons will be traveling towards the target metal, they may interact with the electrons, they may interact with the atoms, they may interact with the molecules. That is undesirable. And there will be secondary effects happening. To eliminate all these things, we need to have a vacuum system where we pump out the air to the desired level so that the secondary effects are minimized. So we use a vacuum pump, and we use a very high level of vacuum in X-ray production. The final or the fifth component is the cooling system. As I said, in X-ray production, enormous heat is generated. Now when enormous heat is generated, so we need to take away all this heat produced out of the system, otherwise it will damage the system. So we must have a strong, robust cooling system. There are other basic things that we have to consider over here. And the basic consideration is, as I told you, in X-ray production, large amount of heat is produced. So we have to take care of this excessive heat produced in X-ray production. That is how it is designed. So we must have a very robust cooler which takes away heat produced